Today we will learn a very important topic in number families, the rational and irrational numbers. Now they are a bit tricky because previously in junior classes, even if we have learned that what are rational and irrational numbers, we are at times confused that what kind of questions are going to be there in the exams regarding rational and irrational numbers. And today we are going to sort it out. First, let's find out what is a rational number. A rational number is any number that can be written as a fraction in form of p by q, where p is an integer and q is an integer, while q cannot be 0. So if a number can be written in pure fraction form, then it is a rational number. Let's go through some example of rational numbers. Is 3 by 5 a rational number? Of course, as two integers 3 and 5 are written in pure fraction form. Therefore, 3 by 5 is a rational number. What about 0.04? Is 0.04 a rational number? At first, it might seem an irrational number, but 0.04 can be written as 4 by 100, and that is pretty clear. Similarly, minus 3 is rational because it can be written as minus 3 by 1. Again, a pure fraction form of two integers. Let's look at some tricky numbers now. Is 3.142 a rational number? You can pause the video and think before you take a decision. If the answer is no, then I know the actual reason for it, as normally 3.142 is confused with the value of pi. Well, as you can see, it is not the value of pi. It is a value close to pi but not actual pi, as it does not have infinite number after the decimal as in the case of pi. Now, as it is clear that it is not pi and it can be written as 3142 divided by 1000, so by definition it is a rational number as two integers are written in pure fraction form. Now let's take a look at 22 by 7. Again, you guys may think it is pi, but it is not. It is a value close to pi in fraction form. So neither 3.142 nor 22 by 7 is pi. Coming back to 22 by 7, since we have two integers in pure fraction form, therefore 22 by 7 is a rational number. Under root 25, is it a rational number? We know that its value is equal to 5, and 5 can be written as 5 by 1. So under root 25 is a rational number. Any number which can be written in form of p by q is a rational number, no matter it is displayed in decimal or under root format. But as long as it can be converted to fraction form, it is a rational number. Now let's look what are irrational numbers. Irrational numbers are those numbers which cannot be written in p by q form, pretty much opposite to rational numbers. Their decimal form does not end in a predicted manner and it keeps on going forever. There are three types of irrational number and I am going to teach you and help you memorize them. You should remember them. First, if there is any pi symbol, not 3.142 or 22 by 7, but the actual value of pi, and pi is always written in the form of pi symbol. Pi has unlimited decimal places in non-predictive pattern. You cannot change it to pure fraction form. The second is square root whose value is not exact. By this I mean you require a calculator to calculate its value and its value has never ending decimal places. Consider under root 5 or under root 6 or under root 7. All are irrational numbers. Similarly, cube root whose values have many decimal places like cube root of 2, cube root of 3 and cube root of 4. Okay, so these are three types of irrational numbers. The symbol of pi, any under root whose values are not exact, and the numbers after the decimal goes on forever. Cube root whose values have many decimal places and goes on forever. Okay, so these are three types of irrational numbers. You can pause the video and memorize these types. Now you may ask why they all are irrational numbers. Let's take an example of pi. As the decimal values does not finishes, So we actually don't know how many zeros are required in the denominator to make it fraction form. As in the case of 0.06, we actually know that we need 2 zeros in the denominator to convert it to fraction form. In 3.142, again we knew that a total of 3 decimals were required in the denominator to convert it into fraction form. But in the case of pi and under root 2, the decimal places never ends and we cannot put exact number of zeros in denominator to convert the decimal into fraction form. The inability to convert a number to fraction form is the main reason it is called an irrational number. Here again you may ask why 22 by 7 or 3.142 are used as the value of pi. If we look at 3.142, pi and 22 by 7 on a number line, then these all are different numbers, but since 3.142 and 22 by 7 are so close to the value of pi, therefore for ease of calculation, many books refer to pi as 3.142 or 22 by 7 while doing any sort of numericals. We use it in our calculation, but they are not the actual value of pi. In fact, exact value of pi is not known to anyone, even to supercomputers. Apart from this, 3.142 and 22 by 7 are rational numbers. Now we will go through some special decimals where a pattern is repeated in its decimal portion for unlimited amount of times. For example, let's look at sum of recurring decimal. If we have 0.3 and there is a dot on the 3, then it means 0.33332 unlimited decimal places. Similarly, 0.125 with dot on 5 means 0.12555, where 5 is repeated unlimited number of times. If 3 and 7 have a dot in 0.137, then it means 0.137, 37, 37 and so on. If we have a dot on all three numbers as in 0.123, then it means 0.123, 123, 123 and so on. So actually the dot means the repetitive part of the decimal portion. Always remember, if a decimal portion has some pattern with repetition, even if it has unlimited numbers, it is a rational number. Let me repeat, recurring decimals are also rational numbers. Converting recurring decimal to fraction is taught to IGCSE students in separate section, for which there would be another video. But you should remember, recurring decimals can be changed into fraction, therefore they are rational numbers, as numbers in pure fraction form are rational numbers. Exam tip: if a decimal ends or repeats, it is rational. If it never ends or never repeats, it is irrational. Here is a trick question. Is every integer a rational number? Yes, because any integer can be written as an integer over 1. For example, 6 can be written as 6 by 1, or minus 3 can be written as minus 3 by 1, and even 0 can be written as 0 by 1. So every integer is a rational number. But not every rational number is an integer. For example, 2 by 3 is a rational number, but it is not an integer. Right? Let's repeat. All integers are rational, but not all rationals are integers. Now let's see some exam question. In first type of questions, you will be asked to identify the type of number as rational or irrational numbers, or at times you will be asked to circle the irrational number. In the first question, we have 22 by 7. By definition, 22 by 7 is a pure fraction of two integers. Therefore, it is a rational number. Next, we have pi symbol. Pretty clear, it is an irrational number because the numbers in the decimal portion are infinite and non-repetitive in nature. 3 under root 5 is irrational as it cannot be simplified into pure fraction. The last one, under root 8 into under root 2, is a bit tricky. The trick is under root 8 itself is irrational and under root 2 itself is irrational. We don't exactly know the value of under root 8 and the under root 2 value. So both are irrational numbers if written independently, but here they are multiplied together. We have learnt in indices that once same power numbers are multiplied or divided together, we can take the power common. So under root 8 multiplied by under root 2 gives us under root 16, which is equal to 4. So now coming back to the actual question. Is 4 a rational number? Yes. Every integer is a rational number because it can be written as 4 by 1. Therefore, under root 8 into under root 2 is a rational number. Alright, in the second section, we have type of question like write an irrational number between 3 and 4. It is a very easy question with a simple approach. Let me explain it. In the first step, we convert 3 into square root form. We can write 3 as under root 9 and 4 as under root 16. So far, we have just converted the two numbers to its under root form. In the second step, we write all the numbers between under root 9 and under root 16 in the same square root form. They would be under root 10, under root 11, under root 12, under root 13, under root 14 and under root 15. All these numbers are decimal numbers with unlimited decimal portion. Therefore, it cannot be converted to pure fraction form of two integers. Finally, you can choose any of the 7 options from under root 10 to under root 15, but don't write multiple answers if only one value is asked. Let's practice another question. Write down an irrational number between 1 and 2. We will again follow the previous method. In the first step, we will write the number in its square root form. Here, 1 can be written as under root 1 and 2 can be written as under root 4. Now I guess you can figure out the second step. Yes, you need to write all the square root numbers between under root 1 and under root 4. We get under root 2 and under root 3. You can choose any of the irrational number and write it in the answer block. Let's go through another example. Write down an irrational number between 7 and 8. Now I am sure you know the drill. You can pause the video and try the question for yourself. Let's check it out if you have solved it correctly. In the first step, we write 7 as under root 49 and 8 as under root 64. Between the rational numbers of under root 49 and under root 64, we have under root 50, under root 51, under root 52 to under root 63. All these square roots between under root 49 to under root 64 are irrational numbers and their answer would be between 7 and 8. So you can choose any one of them. Let's randomly pick under root 57. To sum it up, always ask yourself, can I write it as a fraction? If yes, it is a rational number. Otherwise, it is an irrational number. And secondly, does the decimal portion ends or have a repetitive pattern? If yes, then it is a rational number. If you find it helpful, please share it with your friends to prepare for their exam. Till next lecture, take care and keep practicing.